Dimension is the power to which the fundamental quantities are raised to. So hello and welcome students to another new video of Newton Gate, where we make your dreams come true. So today in this video we'll discuss about the second chapter of class 11, that is units and measurement. So we'll learn about physical quantities first. Their units, dimensions. This will be a new thing we will be studying in this chapter. Significant figures, errors, and last, the most easy thing is rounding off. So these will be the topics we will be studying in this video, and mainly I will discuss about the first 3 points in this video, and in the next video I will discuss about the last 3 points. Okay. The quantities which can be measured by an instrument and describe the laws of physics are called the physical quantity. Okay. A physical quantity is one that can be measured. So to measure a physical quantity like length, mass and time, we require a standard of measurement. This standard of measurement is called the unit of that physical quantity. For example, the unit of length is meters, right? You all know that the unit of length is meters, and a standard length of 1 meter has a precise definition. Okay. So to measure the length of an object is to determine how many times this standard length meter is contained in a length of a room, and the comparison of a physical quantity with a standard quantity is called measurement. Unit is also given here, that this standard of measurement is called the unit of the physical quantity. Okay. For example, length, the unit of length meters is given here. So let's move to the next slide. Okay, so classification of physical quantities. The physical quantities are classified into broadly 2 types. So the physical quantities that are independent of each other are called fundamental quantities. Okay, all the other quantities which can be expressed in terms of the fundamental quantities are called the derived quantities. Next is the units. The reference standard used to measure the physical quantity is called the unit. Okay. Types of unit. Number 1 is fundamental units. The units defined for the fundamental quantities are called fundamental units. Number 2 is the derived units. The units of all the other physical quantities which are derived from the fundamental quantities, very good, are called the derived ones or derived units. Okay. So these are the system of units. FPS system, the foot, pound and second. The CGS system, we know it very well, that is centimeter, gram and second. MKS system is the length in meter, the mass in kilogram and time in second. And SI system, this system is widely used in all the measurements throughout the world. The system is based on 7 basic units and 2 supplementary units. So there are 7 fundamental units here. 7. First is mass. Second is length. Third is time. Fourth is amount of matter. Expressed in mole. Next is temperature. Unit is Kelvin. Next is current, electric current. it has units ampere. Next is intensity of luminous light. It is expressed in candela. So these are the 7 physical quantities which do not depend on other quantities, any other thing. And the derived ones, the derived quantities, there are several, many. It can be velocity, it can be acceleration, it can be density, it can be area, it can be volume. We know the if we try to write the units, the CGS, that is the centimeter gram second, and SI unit, we will discuss about the units also. So velocity, it is centimeter per second. In SI, it is meter per second. So velocity is a vector quantity, we know that very well. It has both direction and magnitude. Acceleration will have centimeter per second square, that is velocity by time, velocity per unit time, and velocity is displacement per unit time, and the SI unit will be meter per second square. Density will be gram per cc, that is cubic centimeter, and this is kg per meter cube. Area will be centimeter square, here it will be meter cube. Volume will be centimeter cube, sorry, the area it will be meter square, and volume it will be meter cube. Okay. So the derived quantities, they depend on the 7 fundamental quantities, that is length, first mass m, L, time t, and luminous intensity candela. It is very less used actually, and temperature, it is expressed as theta or Kelvin something, current I, and mole. These 7 quantities. Now coming to the supplementary units. There are 2. First one is plane angle. It is expressed in radian. And another number 2 is solid angle. It is expressed in steradian. Okay. So plane angle, what is plane angle? So this is the angle theta subtended by the arc length s, and if the radius of this part is r, we get theta is equals to s upon r, arc length divided by the radius. If we complete this thing, we get a circle. So this is a 2-dimensional figure. But in case of solid angle, we have to consider a cone, and in the base of the cone, near its vertex, at this pointed end, we find here a angle is formed, right? We find it in a birthday cap, or in a Christmas cap, or in an ice cream cone. So this is solid angle. It is expressed as omega. So omega is the area. The area is A, the area of this part, and radius r. So it is A upon R squared, radius squared. So if we complete this thing, we get a sphere. So this is a 3-dimensional figure. Whenever we are measuring a physical quantity, there is a number n, and after that there is a unit. Any physical quantity. So in the n portion there is some digit, and in the u we find some units there. So the supplementary quantities or supplementary units, there is the units but no dimension. This is their specific and unique property. So now you ask that, sir, what is dimensions? So now we will study about dimensions. Okay. The dimensional formula of any physical quantity is the formula that tells which of the physical units have been used for the measurement of that physical quantity. How dimensional formula is written for a physical quantity? Number 1. The formula of the physical quantity must be written first. The quantity must be on the left hand side of the equation. Number 2. All the quantities on the right hand side of the formula must be written in terms of the physical quantities like mass, length and time. Number 3. We have to replace mass, length and time with capital M, L and T and write the powers of the terms at last. Take force. Now we know from the second law of Newton's second law of motion, that force is equals to mass multiplied by acceleration. So at first, when we are trying to find the dimensions of any physical quantity, we must know its relation with other physical quantities, right? So mass is a fundamental quantity. So it is a base quantity. We need not to break it to any other fundamental quantity. But acceleration, it is not a fundamental quantity, it is a derived one, so we need to break it. Now acceleration is equals to velocity by time, and velocity is equals to displacement by time. So displacement by time into another time, we can write it as like this also. This time is here, and velocity we have just write it as displacement by time. So we get displacement by time squared, right? So taking the basic thing, the dimension of acceleration then will be displacement is a quantity in length. So we will take L, time is T. So we will take T, LT minus 2, the power. Right? It is what's happening, L divided by T square, that is LT minus 2. It is inverse power, okay, reciprocal. So force, it will be mass, that will be M multiplied by LT minus 2. So that will lead to, that will result MLT minus 2. Reducing relations among physical quantities. To reduce relation among physical quantities, we should know the dependence of one quantity over others, or the independent variables, and consider it as product type of dependence. Dimensionless constants cannot be obtained using this method. Here are a few limitations of dimensional analysis. The method of dimensions has the following limitations. By this method, the value of dimensionless constant cannot be calculated. By this method, the equation containing trigonometric, exponential and logarithmic terms cannot be analyzed. If a physical quantity in mechanics depends on more than 3 factors, then relation among them cannot be established because we can have only 3 equations by equalizing the powers of m and t. Number 4, it doesn't tell whether the quantity is vector or scalar. So here you can see the dimensions of some physical quantities. Definitely these are the derived ones. Homogeneity principle. If the dimensions of left hand side of the equation are equal to the dimensions of right hand side of the equation, then the equation is dimensionally correct. This is known as homogeneity principle. Mathematically, left hand side and right hand side, both the dimensions should be equal. Applications of dimensions. To check the accuracy of physical equations, to change a physical quantity from one system of units to another system of units, and number 3, to obtain a relation between different physical quantities. Here we find that the power of mass is 1, power of length is 1. So what will be the dimension of force in terms of mass? It will be 1. What will be the dimension of force in terms of length? It will be 1. In terms of time, it will be -2. So these powers are the dimensions actually. So we find out the formula of the time period with the help of dimensional analysis. We will not take this K. Now L, G and M, these are the dependencies of the period of motion. That is the time period of the bob. A small bob has been taken here. And L is the effective length, that is the distance from the point of suspension to the center of the bob, but as the bob is very small, its radius is neglected here, so we take the length of the string as the effective length L, small l. G is the gravitational acceleration and small m is the mass. Now the dimension of L, small l is capital L, dimension of small g is Lt minus 2, it is acceleration, and mass is capital M, and we write the powers x, y and z after the third bracket. So here the fundamental terms M, L, T, they are raised to some variable powers. There are a number of variables, we can make that specific number of equations. So here are 3 variables x, y and z. We'll make 3 equations involving them. So we get the values of x, y and z as half, minus half and 0 respectively. So the original equation reduces to capital T is equals to K root over L by G. So this is a very interesting example. So I want all of you to pause the video at this point and note these 6 problems on your copy and come solving these questions in my next video. Okay, so that's all for today. Thank you for watching the video. Bye bye.